and this is my second attempt. Get 2023 was my second attempt.
Okay, good. So I hope these sessions will help you. So who else is Prajwal? Thank you. Thank you for joining.
Thank you, sir.
Prajwal.
Good evening, sir. I am Prajwal Gaute, and I am currently doing BTech, and I am in final year. So I am. This is my first class in NPTEL GATE course.
So did you attempted GATE before? Is it your first attempt?
Yes, sir. It's my first attempt.
Okay, all the very best, and I hope these sessions will help you. So yeah, Pratyusha. Okay, okay, let's get started. It's already 6:08. We'll get. So what I'll do is that I'll share my PPT. So as I mentioned in the website, today we will discuss about flow through, so losses in pipes. So typically what we do is that we'll talk about the topic, and later we will solve two gate questions, 2 marks gate questions. So while solving these questions, I'll give you the hints how you can solve quickly these all these type of questions. So let's get started. But whether you can able to see my screen?
Yes, sir. It is visible.
Can you able to see my slides moving?
Yes, sir.
Yes, sir.
Thank you. So let's get started. So this is a phase two of live interaction sessions. So phase one has completed already. So in the phase one, I have taken eight sessions, eight plus two additional session, total 10 sessions. This is a phase two. Already we completed one session. This is a session two. So let me introduce about myself. My name is Kannigandu Bhargav Kumar. I'm PhD student in Indian Institute of Science, Bangalore. Okay. So let's get started. So as I mentioned earlier, today we will talk about losses in pipes. So so what we do is that we broadly introduce the topic of what we mean by the losses in pipes, and how we can quantify these losses, and how we can suppose, let's say, if we connect a pipe in multiple series, how we can quantify the discharge and head losses to the pipes. All these things we look at, and additionally we'll solve two gate questions. One is from gate 2022, very recent one, another is from gate 2015. So these two are important questions. Okay, so when I say losses in pipes, what are the two losses we know? One is major loss, and another is minor losses. Okay, so these are the two losses which will be encountered by the flow when it is flowing through the pipes. Okay, suppose, look at this particular picture. This is reservoir A and this is reservoir B. Suppose, let's say, flow is taking place from reservoir A to reservoir B. When the flow is taking place from reservoir to reservoir B, this flow encounter multiple losses. So on these type of losses are majorly classified as two types. One is major losses, another is a minor losses. Okay, so look at this particular picture carefully. So there is a dashed line here at the bottom, which is termed as a datum. So when for all the kind of energy calculation, fluid mechanics and open channel, we take one arbitrary datum. So with respect to the arbitrary datum only, we will calculate the energy level. For an open channel flow, we take channel bed as a datum, and whatever and that particular energy we termed as a specific energy, which I talked about, which I talked was in last class. So today we'll talk about the total energy. So what is the total energy? Which is E equal to pressure head plus velocity head plus datum head. Suppose energy available with water at any point in the flow can be defined as total energy. So it is a combination of all these three energies, which is pressure energy as well as a kinetic head or velocity head and datum head. Suppose if I look at this particular point and look at and compute the energy available with water, so that total energy is known as the total energy. And suppose what we do is that, let's say with respect to the datum, if we draw total energy available at all the points along the flow line, that particular line is called the total energy line. And there is another line called hydraulic gradient line. See, these two lines are very important for the IAS and one mark question exam, one mark questions. So the total energy line is a line which represents the total energy available, which is total energy available in the fluid at any point. Whereas hydraulic gradient line is represents the pressure head plus datum head energy available available with the fluid. So total energy, how we can get the hydraulic gradient line? So hydraulic gradient line we'll get with respect to, suppose if we remove this a square by 2g, the resultant p by w plus z, this particular height and the line drawn with respect to these two terms is called hydraulic gradient line. So the 2 marks, like 1 mark question, you can expect as like suppose total energy line is a sum of, so we can say pressure head plus kinetic head plus the datum head, and as well as hydraulic gradient line is the represents, and which is sum of pressure head plus datum head. Like this we can you can expect 1 mark questions from that. So that is not of our interest. Our interest is to look what type of losses will filter while it is flowing from the reservoir A to the reservoir B. Suppose when the flow enter into the pipe, it experiences entry loss. Okay, and as the flow enter the pipe, after entering the pipe, it flows along the pipe. Suppose if we draw exaggerated view of the pipe, let's say this is a pipe and flow is taking place in this direction, and you can see there is a friction force which acts opposite to this direction of flow. Because of this friction force, the head available, see, I can use head and energy are interchangeable words. When I say head and energy, these are mean to be same. Suppose whatever the head available with the water will be reduced because of this friction force. Okay, suppose so, and as well as after flow reaches at this particular location, it exists it exit it exit from the pipe and enter into the reservoir loss, and it encounter another loss called exit loss. So suppose, let's say, while flow is taking place from reservoir A to the reservoir B, it encountered three losses. One is energy loss, another is loss due to the friction, and exit loss. Okay, suppose suppose, let's say, and now this is a case. Now let's say I wanted to understand how we can compute the major loss. So to compute the major loss, there is a formula given by the Darcy. Okay, so the equation for head loss in the pipes due to the friction is given by the Darcy, so which is nothing but FL V square by 2ZD. This is a very important formula. So the derivation is out of scope for this session, but the derivation is available in the source, which is Modi and Seth. I can share you the book at the end of the session. Okay, so there is a pretty long derivation to arrive this particular formula. This derivation basically uses the same total energy equation at 1 and 2, so we can able to derive this thing. So the derivation is available in the Modi and Seth book. It can be, I'll share the book at the end of the session. Okay, so let's say this is a HF equal to FL V square by 2DGT. So let's see what are the terms. F equal to the friction factor. Okay, L is the length of the pipe. Sorry, L is the length of the pipe, and V is the velocity in the pipe, velocity of the flow. Okay, V is velocity, and G is acceleration due to gravity. D is dia. Pardon me, my handwriting. Okay. Let's say consider the pipe is circular. So what is the area of the pipe? 5/4 into d square. And as we know, discharge equal to area into velocity. Let's say if I reshuffle the term, and if I take the a to this side, it will become q by a. And suppose if I substitute a with this 5/4 d square, then I'll get a 4/4 q pi d square. Suppose let's say if I substitute this in the HF equation, HF equal to FL into, in place of V, I substitute 4Q divided by 5 d square as from here, divided by the 2G. Let's say assume G equal to 9.8 meter per second square. Then this HF equation will be so, will be converted in terms of Q, which is nothing but HF equal to FL Q square by 12.1 into d power 5. This is very important while solving the question. So this is a general formula. This is a general formula. But in the most of the question, our interest is to estimate the discharge. So in that case, rather than like deriving using this general equation and arriving at this particular cube, maybe sometimes it's difficult and it takes a lot of time. But in the gate exam, you need to solve very quickly. So in that cases, this particular type of equation will be very helpful. So kindly remember this equation: HF equal to FL Q square divided by the 12.1 into d power 5. Okay, let's look at another classical example here. So this is, let's say, this is the reservoir A and this is reservoir B. And so this reservoir A and reservoir B connected with the three pipes in a series. Now, can you help me to identify what type of losses the flow encounter while it is flowing from reservoir A to the reservoir B? I expect a participation in here. So kindly anybody what is the initial loss it experience? Hello.
Sir, may
At
I
this
answer?
point, what loss we can flow encounter?
Uh, it is inlet loss.
In inlet, correct, inlet or entry loss. Okay.
Sorry,
And
entry
and
loss.
and
Then
as well flow takes place in this pipe, what losses it will encounter?
this is
Loss due to
Darcy
friction.
Weber.
Correct. So
Yes.
which is
Friction loss.
nothing but loss due to friction. Okay. And if you observe clearly here, what is happening? The pipe is suddenly contracted. So because of
Contract.
this, yeah, loss due to traction.
Sudden contraction.
Correct. Sudden contraction. Very good. And after the sudden contraction, the flow again takes place in this pipe. Then again,
Loss
what
due to
friction?
expansion.
Loss due to friction. And after that, suddenly the pipe is expanded. So what loss we can
Expansion.
expect? Correct. Sudden
Loss due
expansion.
to expansion.
Sudden expansion. And again, the flow takes place in this pipe. Then again, we'll get a friction loss. And at this point, the flow exit. Then what type of losses we encounter? Exit loss. Okay. Suppose if one want to understand the total head loss from the head loss in a flow from reservoir to A to reservoir B, we have to sum all this loss of energy to get this head. Okay, head difference in the flow level. Okay, suppose let's see what are these minor losses, the formulas. Suppose as I mentioned, losses are classified into two types. So one is major loss, another minor losses. The very first one is loss of energy due to sudden enlargement. As we have seen, and when the pipe 2 to pipe 3, the diameter is suddenly enlarged. So because of the sudden enlargement, the flow encounters some loss of energy, which can be computed using this particular formula, which is equal to V1 minus V2 square divided by the 2ZD. So V1 will be the pipe 1, velocity in pipe 1, and V2 will be velocity in pipe 2. So it does not matter which one is has a higher diameter at the end, because we are using square, it will be the value will be positive only. Okay. The next one is loss of energy due to sudden contraction on entrance. So for the entrance and sudden contraction, we have the same formula, HL equal to K into V square by 2GD. Here is a K is a coefficient which will be given to you. Typically the value is 0.5. Okay, loss coefficient. Okay, and next one is loss of energy at the exit of pipe, which is equal to HL equal to V square by 2G. Okay, and loss of energy in the bends, which is K into V square by 2G. See, all these energy losses can be written in this general form, K into V square by 2GD. K will be vary from the enlargement, entrance, and pipe. So if you remember this HL equal to K V square by 2G, then you can able to solve all the calculate all the energies. Okay. Similarly, loss of energy in various pipetting K into V square by 2G. And then last one is sixth one, the loss of energy due to gradual contraction and enlargement. Suppose in the first formula we have seen sudden enlargement. Suppose rather than the sudden, the pipe is contracted slowly, like in this manner. Then how this loss of energy will be calculated? This will be calculated using this particular formula. HL equal to K into V1 minus V2 whole square divided by this 2G. So this form, the more details about these formulas are given in this reference, Modi and Seth. Okay, you can refer to that if you have any further queries. So let's quickly solve one very like important question which covered all these losses. Okay, let's read the question along with me. This question is from GATE 2015, set 1. The question number is 53. The question is as follows. Two reservoirs are connected through a 930-meter long and 0.3-meter diameter pipe, okay, and which has one gate valve. The pipe entrance is sharp with a loss coefficient is 0.5, and the valve is half open, and the loss coefficient corresponding to the valve is 5.5. Now the head difference between the reservoir is 20 meter. Now assume friction factor for the pipes as 0.03 and acceleration due to gravity is 10 meter per second square. Okay. Now the discharge in the pipe accounting for all the minor and major losses. Suppose let's say if after accounting all the major and minor losses, what is the discharge in the pipe? We have to calculate. Let's draw this figure, how it looks like exactly. Let's say. So this is reservoir B, this is reservoir A. Okay. And suppose let's say there is a gate valve here. Okay. Now this is a flow level here. This is the water level. So this is the water level here. And the how much diet is given? 0.3. Okay. Now, can you help me to identify what type of losses it will encounter while flow takes place from reservoir A to reservoir B? Kindly please help me here. So, what type of loss it will encounter here? Entry loss. Correct.
Entry, exit.
Entry, exit. Correct. Entry, exit.
Friction.
Friction. Very good. Loss due to friction. And
Gate
additionally,
valve 2.
correct. Additionally, we have a gate valve. Because of this gate valve, we have loss due to gate valve also. So as we seen in the previous slide, loss of energy due to sudden contraction, which gives us HL equal to K into V square by 2G, and exit V square by 2G, and as well as various pipe fittings K into V square by 2G. So we'll use the same equations only to calculate the head loss. Okay, and what are the given? Length of the pipe given as 930 meters, and diameter of pipe given as 0.3 meter, and head difference between these two reservoir given as 20 meter, and the friction factor is given as 0.03, acceleration due to gravity as 10 meter per second. So as you identified, there are 1, 2, 3, 4. Total 4 losses are there. Okay. Now let's see. So can you give me an idea how we can solve, how we can compute the discharge here? So which is Q equal to A into V. Okay. Anybody give a hint how we can do? Okay. Let's move further. As we have seen in the previous slide, so when the flow takes in place from the reservoir A to reservoir B, we identified it will encounter entry loss, it encounter loss due to friction, it encounter gate valve loss, it will exit loss, and these are the formulas for this process. So entry loss will be 0.5 v square by 2g, because this has given loss coefficient as 0.5 for sudden entrance. Okay, and loss due to gate valve, how much gate valve? K is given as 5.5. Okay, so in the question it is given 5.5 and 0.5. Okay, so we use the same case only. So interval will be delta H equal to 0.5 v square by 2g, and here this is total FL v square by 2gd. But for sake of convenience, I separated FL divided by d as and v square by 2g as, because the common term in all the terms are v square by 2g. So I want to take out the v square by 2g. So that's why I have written it separately. So then it is this is gate wall loss 5.5 into v square by 2g, and this is exit loss. So now what we know here, what are the unknowns, what are the knowns? So we know g is g comma d comma delta h are known. What is unknown? V is unknown. Here velocity is unknown. So if we can compute the V, then Q equal to A into V, we can directly use and we can calculate the discharge. So can anybody try quickly and say me the answer? So how you can do is that delta H equal to V square by 2G, you can take it out directly. So 0.5 plus FL divided by D plus 5.5 plus 1. So in this way you can separate it out. It will be easy for you. Then F is given 0.03, L is given as 930, D is given as a 0.3, and these are the only one substitution here. Directly you can get, and the G as 10. Okay. So can anybody say what is the velocity value? The velocity will be 2 meter
Sir,
per
2.
second. Correct. Very good. Very nice. 2 meter per second. So since as we know, discharge Q equal to A into V. So let's say here the pipe is given as a circular pipe. So area will be pi by 4 into d square into V. Here velocity is known, d is known. Then directly we can compute the discharge. So pi by 4, d is given as a 0.3 meters, 0.3 whole square into 2. So the answer is 0.1413 meter cube per second. Okay. So what they have given, so they asked if it's a fill in the blank, so directly you can fill the answer. Okay. So any doubts with this question? Okay, let's move to the next topic. Suppose as now we have seen the single pipe which is connected between the two reservoirs. Suppose let's say there are multiple pipes which connected in a series between the reservoir A and reservoir B. So how you can compute? So as you identify in the previous slide, like very in the second slide. So when the flow enter into this particular location, we it exit and experience entry loss due to friction in the pipe one, exit loss. Sorry, not exit loss. This is a sudden contraction and loss due to friction. Sudden loss due to friction in the pipe two, and sudden enlargement in the pipe from 2 to 3, and friction loss in the pipe 3, and as well as exit loss. Okay, so as you identified, so suppose if I look at this head level difference between these two reservoirs H, which will be equal to the sum of all these losses. Okay, Suppose suppose let's say pipes are connected in the series. If a pipeline connecting two reservoirs is made up of several pipes of different diameter D1, D2, D3, etc., and which has a length of L1, L2, L3, etc., which are all connected in the series, which means that like one by one next to the one. Okay, then the difference in the liquid surface levels is equal to sum of the head losses in all the sections. So it is given as difference in the head level, which is head H. Difference in the liquid surface level is equal to sum of head losses in all the section. So to suppose if I want to, if my interest is to compute the head loss from the reservoir between the reservoir to the reservoir A to reservoir B, then I need to sum all the head losses which encountered by the flow between the reservoir A and reservoir B. Okay, and additional, this is the first condition. And the second condition is that since these pipes are connected in the series, okay, the mass which will enter into this pipe 1 will be equal to the mass enter into the pipe 2, which means that the discharge is same in all the pipes. Okay, this is another important pipe. Okay, which means that q1 equal to q2 equal to q3 equal to q. So how much our mass is enter into the pipe, is the same mass will exit. Okay, so these are the two conditions you must remember to. So let's see in another special case where pipes are connected in the parallel. Suppose a main pipeline divided into two or more parallel pipes which again join together at the downstream and continue as a main line as shown in the figure. Suppose let's say this is a pipe, main pipe, which is divided into two pipe, pipe 1 and pipe 2, and again connected to the main pipe at the downstream. Okay, then these pipes are said to be parallel. Okay, the pipes are connected in the parallel in order to, why do we connect these pipes in parallel? To increase the discharge. Suppose like if my interest is to increase the discharge with without suffering the length. So what we do is that I can connect multiple pipes in a parallel to increase the discharge in the to the main. Okay, what are the conditions? So the conditions is that the mass which enter the pipe 1 and pipe 2 together will enter into the main pipe. Okay, q equal to q1 plus q2, and since these both, okay, since these both pipes experience a similar kind of head loss, okay, so then the head loss in the pipe 1 and pipe 2 will be equal when this pipe both are connected in a parallel. So in the previous case, what we did, so head loss will be sum of all the head losses at all the section. In this case, head loss will be the sum, and where discharge is same. But in a parallel case, discharge is sum, whereas head loss is same. So there is a this is a major difference between the when pipes are connected in parallel and pipes are connected in the series. I hope this difference is clear for you. If you have any doubt, you can stop me here. Okay. So let's solve one another interesting example from GATE 2022, which is very recent exam. This is a very recent one. Last year, 2022 set one. The question number 57. Like, how many of you seen this question? Can you just mention like? Okay. Anyway, let's proceed further. This is a GATE 2022. The question is from GATE 2022 set one. Question number is 57. So the question is as follows: two reservoirs are connected by two parallel pipes. So when the pipes two are connected in parallel, then what are the conditions? Q equal to Q1 plus Q2 and H of 1 equal to H of 2. So these are the two conditions to be remembered when the pipes are connected in parallel. Of length and diameter of 20 centimeter and 10 centimeter. Of same length, actually, the mistakes of same length, and of diameter 20 centimeter and 10 centimeter. So the two pipes have a different diameter, 20 centimeter and 10 centimeter, as shown in the figure below. So this is reservoir A. Let's say this is the reservoir B. Both reservoir connected with the pipe 1 and pipe 2. Let's say two pipes which have a different diameter but a same length, 20 centimeter and 10 centimeter. Okay. and the difference in the water level in the reservoir is 5 meter. Suppose let's say there's a difference in the water level in both reservoirs is 5 meter, then compute the ratio of discharge in the larger diameter pipe to the discharge in the smaller pipe. So let's say in this is we denoted bigger pipe as 1 and smaller pipe as 2. Then our interest is to estimate Q1 by Q2. How much is Q1 by Q2? So consider, so in this case they mentioned clearly mentioned what type of losses you need to consider and what type of losses you need to ignore. So consider only loss of due to friction and neglect all the other losses. Okay, and assume friction factor to be the same for the both the pipes. Okay, so can anybody guess how we can solve this question? So one small hint is the HF equal to FLQ square by 12.1 d power 5. Suppose when G equal to 9.8 meter per second. Can we use this equation and come out with something? Anybody guess? This is one step solution, but it is for 2 marks.
Sir, Q square is equal proportional to D to the power 5.
Very nice. So Q square directly proportional to the d power 5. Let's say if I Q1 square divided by Q2 square, which is equal to d1 power 5 by d2 power 5. So how we can get Q1 by Q2 equal to square root of d1 power 5 by d2 power 5. So can you say the answer? See, this is a one step answer, but it is given for 2 marks. So the only trick in this particular question is that you need to know these two conditions. When pipes are connected in parallel, the discharge is sum of the pipe, sum of all the discharges, whether the head loss is same. And can you quickly say the answer? So here, let's say, what is the
Sir,
denominator?
5.65.
Very nice, correct. Okay, so let's see the solution for the benefits of others. Okay, what is the question? This is a question. So where the two reservoirs A and B connected. So with different two pipes, which is in parallel. So what has given pipe length L1 and L2 equal to the same. Diameter of pipe D1 equal to 20 centimeter. Diameter 2 equal to 10 centimeter. What is the difference in water level? 5 meter. This is not required for our solution because since our interest is to estimate Q1 by Q2 only. Okay. So the question is that what is the Q of larger dia divided by the Q of smaller dia? So as we have seen in the previous section, conditions when pipes are connected in parallel, the head loss in both the pipes is same. The total discharge is equal to sum of individual discharge in the pipes, which is equal to Q1 plus Q2. As we know HF equal to FL Q square divided by the 12.5 into D power 5. So suppose from this particular equation, condition 1, HF1 equal to HF2, which is nothing but F1 L1 Q1 square divided by 12.1 into D1 power 5, F2 L2 Q2 square divided by 12.1 into D2 power 5. As we know, F1 F2 and is equal to F, L1 and L2 equal to 1. So we can directly cancel this. 12.5 and 12.5 is cancel. So what we left out? We left with these four terms, which is nothing but Q1 square divided by D1 power 5 equal to Q2 square divided by the D2 power 5. So now what do? I reshuffle the terms. So I'll bring this one and take this one out the other side. Q1 square divided by the Q2 square equal to D1 power 5 divided by the D2 power 5. So what I'll do, I'll apply square root. So then D1 power 5 divided by the D2 power 5. Then as we know, D1 we know, D2 we know. Suppose D1 given as 20 centimeter, or we can write it as a 0.2 meter. D2 given as 10 centimeter, which can be converted into meter 0.1 meter. So I can directly substitute this value and I got the 5.65 answer. Okay. This is question 2. So you have any doubts here? So any doubts so far? So this is
No,
that
sir.
is all from my side today. Yes, Rahul. Please, if you have any doubt, you can say. So that is all from my side today. So, okay, like any confusion or any clarity you require on the topics so far we discussed, any problem you face difficulty to understand? Okay, so there are multiple things I'll mention. So in the first section, as I mentioned that I given the mail ID. So many of you have approached me for the gate material. I have shared a few members. Okay, suppose if you did not approach to me, still you can approach. I can provide the whatever the gate material I have with me. So my mail ID I am giving here. I have a material short handwritten notes for all the subjects which may be helpful for you, which I can share via mail. So I kindly note down my mail ID here, which is and I'll share all the material whatever I have via mail. And the reference book I'll add here. So the Modi and say I followed the Modi and say for this discussion. So which can be downloaded from here. See, I'm very open to discuss if you have any other difficulties also. Please follow this link which I pasted in the chat box to Anju, what you have? You have any doubt? So I pasted the link here. You can follow this link to download this reference book Modi and say. I'm saying this is a classical book you can follow for the gate, especially if you solve problems from this gate book, this particular book, you will able to solve all the problems from the fluid mechanics. Especially, I got very benefited from this book. Okay, so I'll give you the major of areas where you can focus. Suppose this stream function, velocity potential function. This chapter is very critical, and very nice examples as given in this particular reference book. You can solve those examples, and you will get will get benefit. And additionally, this losses of pipes. This modern share book has a very nice examples for the losses of pipes. You can solve. So the my major suggestion is that suppose if you want to secure good marks in the fluid mechanics, I urge to follow modern textbook. Apart from whatever the material you have, you must solve all the examples thoroughly. I'm definitely if you follow these rules, I'm definitely that you will be able to score 10 out of 10 of fluid mechanics. I usually you know that fluid mechanics has a ratio of 10 out of 100 in the gate exam. So you will be able to score 10 out of 10. Okay. So any other further questions we have? Any questions related to the PSUs or MTech opportunities or PhD opportunities? So this session is not only meant for the one way, like it is kind of interactive session. So where you can approach me for any kind of suggestions, I'm openly discuss with you. Not only for related to the water resource, even other subjects also I can able to provide. Any questions if you have any?
Sir, not now, but next time.
Thank you, Rahul. Thank you. Others have any questions? How to get out? Nikesh Sharma, so suppose like there are two ways to get a PMRF position. One is that right after the BTech, you can apply for this PMRF position, and a second option is that either you can enroll for the PhD in any IITs or IISc. See, the first option considered that you did your BTech from either NITs or IITs. Suppose if you finished your BTech from either NITs or IITs with a CGPA more than 8.0, then you are eligible for the PMRF direct batch. Okay, provided that you clear the interview and you have a good proposal. And the second option called lateral entry scheme, which has launched very recently. Yeah, yes, yes. Obviously, gate score is very helpful for the PhDs and IITs. So let me go back to the PMRF thing. So there is another scheme called lateral entry scheme. Suppose if you are any enrolled student in IITs or IIScs, you are eligible to apply through lateral entry scheme for a PMR fellowship, provided that you have a CGPA more than 8.5 and you should have solid research proposal. If you met this requirement, you are encouraged to apply for the lateral entry scheme. Okay. Yes. Is GATE score useful in applying for a PhD from IITs? Yes. GATE score is definitely helpful. I give my example. I entered into IISc via through GATE score only. Okay. So as I mentioned, I did not mention. I actually attempted GATE two times. One was in 2015, another was in 2018. Both the times I attempted. 2015 was for the MTech. 2018 I attended for the sake of PSUs. Okay, so both the times I did the self preparation only, and in 2000, based on the 2018 GATE score, I got this, and addition to my interview, I got the PhD seat in IISc. So it is very beneficial if you have a valid GATE score before applying for the PhD position in IITs and IISc. Will there be any class for the transportation? Uh, okay, currently there is no PMR fellow transportation. So currently we have a structure, geotechnical and environment engineering. Maybe I can take your request into consideration and ask national NPTEL committee to incorporate any PMR fellow. Okay. Ajay, you have any query? Okay, Ajay. And it's not only my class, even you please attend other live mentoring sessions also. Like you have another session on Thursday, Saturday. So please do attend for all these sessions, and I'm definitely you will learn from their experience. Okay, myself, just for the best for the MTech. See, suppose like it depends upon what you want to do, Ajaz. Suppose if you want to pursue research, I'm definitely to encourage you water resource engineering because there are a lot of opportunity for water resource engineering, provided that you are enthusiastic in doing research. Suppose your goal is to get a job and do some private job and anything, then I urge you to take structures first and ask after the transportation. Okay. Is it clear, Ajaz? Thank you. Any other queries? But one more thing is the structures require a lot of mathematical understanding. Suppose if you plan to do MTech in structures or geotechnical, any branch, you may require a lot of understanding on mathematics, especially this probability statistics and advanced numerical methods and all, FEM and all. So you kindly take the electives in your fourth year, which may help you for the MTech. Like in your fourth year, you will have a choice to choose electives. Now, like then you must take electives, tough electives, which will really help you for the MTech, like the finite element method, probability statistics, transportation engineering, transportation systems. Your department may offer different electives. Now you must take the electives, which will really help you for the your MTech. Okay. Any other queries? Mm. Uh, Any other queries you have? You can openly message. Like you can drop a message if you are afraid to talk. Can you provide the notes and prepare PPTs for them? Yes, sure. I mentioned. So I please note down my mail ID. You drop me a mail. Mention subject clearly that request for the gate materials, and I'll provide the all whatever the gate material I have with me. I'll provide share with you. And this current PPTs and recording will be available in the NPTEL website. You can directly access from the website. Okay. Is it clear, Sohil? Sohail, sorry. Any other queries you have? Thank you very much. Okay, it's already 6:54. If you have any queries, you can stay back. Otherwise, you can leave the meeting.